This video is hypothesis testing full examples. So let's review what's involved in a hypothesis test. The first thing that you need to do when you have to do a hypothesis test is identify the claim. What claim has someone made? And then use that to write your hypothesis statement. So you'll need a null and an alternative hypothesis statement. The null, H0, is an equality statement with an equal sign, and H1 is an inequality statement, so it will either be less than, greater than, or not equal to. Once you do that, you need to choose which type of test. Right now, we've only been through Z, T, and one prop Z test. We actually haven't tried all three, but we've talked about them in previous videos. So you pick which test you need to run. We run a Z. We run a Z test if we're testing a mean and we know the population standard deviation. We run a t-test if we're testing a population mean and we don't know the population standard deviation, but we do know the sample standard deviation. And we run a one-prop z-test if we're testing a proportion. Now, once you do that, be sure to write down the input values that you're putting in your calculator. That's how you're going to show your work. Once you calculate this test in your calculator, you are going to get a p-value. That p-value you will compare to a significance level. If your p-value is less than or equal to your significance level, you will reject the null. Reject the null. If your p-value is greater than the significance level, you are going to fail to reject the null. So, if it is less than or equal, we reject. If it's greater than, we fail to reject. And then once we do that, we write the conclusion based off of whether we rejected or failed to reject the null. Most of the time, this little template here will work. If we reject the null, we say there is enough evidence to support the claim that, and then be sure to use the context from the problem to explain what the claim was so that we know what we're supporting. And then if we fail to reject the null, then that means there is not enough evidence to support the claim that. Insert claim. Okay, so these are the steps. You want to write those down so that you have those in front of you. I will be looking for the hypothesis statements, the type of test along with the input values you're putting in. I'm going to look for the p-value and whether you reject or fail to reject the null, and then I'm going to look at your conclusion. All of those are parts of the hypothesis test that you need to make sure that you have. So let's just start working examples. This PowerPoint that I'm going through in the video has so many examples. Just check this out. 18 examples. So it's going to take a while to get through, but at the end of this thing, after you practice all of these hypothesis testing questions, you should be in good shape. Okay, a study by the web metrics firm Hitwise showed that in August 2008, the mean time spent per visit to Facebook was 19.5 minutes. Assume that the standard deviation of the population is 8 minutes. Suppose that a simple random sample of 100 visits in August 2009 has a sample mean of 21.5 minutes. A social scientist is interested in knowing whether the mean time of Facebook visits has increased. Conduct a hypothesis test to determine this. Use a significance level of 0.05. So this is the claim. The claim is what the social scientist is interested in knowing. That's what we're conducting the hypothesis test to determine if this is correct. So we're testing a mean. So the first thing we do is we write our null and our alternate statement. So for our null, we're going to say the mean equals some number. And so for our alternative, we're also going to say mean or mu. Let's see, what was the claim? The social scientist is interested in knowing whether the mean time of Facebook visit has increased. Increased from what? So let's go back and reread the question. A study by the web metrics firm Hitwise showed that in August 2008, the mean time spent per visit to Facebook was 19.5. Assume the standard deviation is 8. Suppose a simple random sample of 100 visits in August has a sample mean of 21.5. So we want to know if it's increased since the 2008. So since the 19.5. So increase would be greater than 19.5. We're going to assume that the mean is equal to 19.5 because that's what it equaled in 2008. So we're going to assume it's the same until we can prove otherwise. So the null, mu equals 19.5. Alternate statement, mu is greater than 19.5. So what kind of test are we going to run? That's the next thing that you need to decide. So I'm looking here, I'm testing a mean, so I know that I either need to do a t or a z. So I'm going to go look for the standard deviation, and it's right here, 8 minutes. So I'm going to read the sentence that is in so I can determine if it's the population standard deviation or a sample standard deviation. It says assume the standard deviation of the population is 8 minutes. So that one is a giveaway because they use the word population in reference to the standard deviation. So this 8 is sigma. It's a population standard deviation. If they give us a population standard deviation, we will be running a z test. Now when we run this in the calculator is going to ask us quite a few things. It's going to say what is the null, what is sigma, what is x bar, what is n, and then what's the alternate statement. So we're going to fill those in. The null is 19.5. Sigma, we already said was 8. X bar is the sample mean, that's 21.5. N is the number in the sample, which would be 100. The alternate statement, we're saying that it's greater than mu0. And then you're going to hit calculate and find a p-value. So in the calculator, I'm going to hit stat. I'm going to go over to test. I'm going to choose number 1, z-test. They've given me statistics, so I choose stats. Mu0 we said was 19.5. Sigma is 8. X bar is 21.5. N is 100. Then for our null, we make sure we choose greater than. And then we choose calculate. And we get P equals 0.0062. If you have a question that asks for the test statistic, that's right here. Z equals 2.5 would be the test stat. But what we're really interested in for us to make our decision is the p-value. So I'm going to write that in. I'm going to write it in red. P-value is 0.0062. Now we are comparing that to our significance level, which is 0.05. So how does this compare? So what you do is you want to, if you're not familiar with comparing decimal numbers, you start at the decimal and compare each number individually that's in the same spot. So I'm going to compare this 0 that's after the decimal to this 0 that's after the decimal. They're the same. So I'm going to move to the next number. I'm going to compare this number in the second spot after the decimal to the second number after the decimal here. This one's 5. 5 is bigger, so 0.05 is bigger. That means 0.0062 is smaller, so it's less than. And remember, if it's less than, we reject the null. And the reason is, just go through the reasoning again. The reason is because this p-value is the probability that if the mean is really 19.5, the probability of us taking a sample of 100 and getting a sample mean of 21.5 is 0.0062, which is less than a 1% chance of getting that. So it's very, very unlikely. So if it's that unlikely, then there must be another explanation, and that explanation would be that our assumption that mu equals 19.5 is probably incorrect. That's why we reject it. Okay, so next we're going to write out the conclusion. So when we reject the null, there is enough evidence to support the claim. So we would write, there is enough evidence to support the claim that the mean time of Facebook visits has increased from 19.5 minutes. So be sure when you say that you support the claim or you don't have enough evidence to support the claim that you actually define the claim in the conclusion so that we know what we're supporting. And again, because we rejected the null, we said this null is not accurate based off of our p-value. Because that's not accurate, that must mean that the alternate statement is true. That's why we can say there's enough evidence for it. Okay, so this is example 2, average male height. According to the National Health Statistics reports, the mean height of U.S. men is 69.4 inches and the population standard deviation is 2.84. And a sample of 300 men between ages 60 and 69, the mean height was 69 inches. Public health officials want to determine whether the mean height for older men is less than the mean height of all men. Conduct a hypothesis test to answer. So pause the video and then make sure that you do your alternate and null statements. Choose your test, p-value, decision, reject or fail to reject, conclusion. So pause and then come back when you're ready to check your answer. Okay, they gave us the population standard deviation and we're testing a mean, which means we run a z-test. The null is mu equals 69.4, which was the height of U.S. men, according to National Health Statistics reports. And we're testing to see if the height of older men is less than that, less than the 69.4. So that's the alternate statement. Fill in these numbers here into your calculator for a z-test. We get a p-value of 0.0074. which is less than 0.05, so we reject the null. So there is enough evidence to support the claim that the mean height for older men is less than the mean height for all men. All right, child weight. Again, read through this and pause the video, try to work through it, and then unpause it when you're ready to check your work. Okay, we know the population standard deviation, so we're running a z-test. We are writing the null as 49.3, so mu equals 49.3 because that was the weight in 2002. We're assuming that's still true until we prove otherwise. We're trying to see if it is greater than that. We're trying to conclude that the mean weight of 6-year-old girls is higher in 2006, so we would use the greater than sign. Fill in our z-test like so. P-value is 0.0208, which is greater than the significance level of 0.01 because 2 is bigger than 1 right there. So we fail to reject the null. If we can't reject the null, then we don't have enough evidence to conclude that the mean is greater than 49.3, which means there is not enough evidence to conclude that the mean weight of 6-year-old girls is higher in 2006. Or you could say there is not enough evidence to support the claim that the mean weight of 6-year-old girls is higher in 2006. Okay, so we are going to stop this video here and we'll pick up with part 2 with example 4.